हेलो डियर स्टूडेंट, वेलकम टू यू माय यूट्यूब चैनल तोमर स्टडी सर्कल। आज हम एक IIT जेई 2021 एडवांस की प्रॉब्लम को डिस्कस करेंगे। इस प्रॉब्लम में एक रोड है जिसका वेट W है और ये हॉरिजेंटली इस तरीके से फिक्स है। एक रोप है जो इसके अनदर एंड से गुजर रही है। रोप पे एक लोड सस्पेंड किया गया है जिसकी वैल्यू अल्फा W है। ये लेंथ L गिवन है, रोड की लेंथ L है और बेसिकली दिस लेंथ इज ऑल्सो गिवन एज L। Hence, these angles are 45 degrees and 45 degrees. Want to solve the problem? Here, first we consider the free body diagram of the road. The forces acting on the road are shown here. At O, in normal reaction act, the normal reaction has two components, one along the road NX and another component act along the vertical to the road N. The weight of the road act at its midpoint vertically downward W, and this force alpha W load act downward. Another force acting in the rope is tension T. Here it is at an angle of 45 degree from the road. The tension can be break in two components, one along the road and another perpendicular the road, that is T sin 40. Okay, the problem is based on the equilibrium. First we consider the rotational equilibrium. On taking rotational equilibrium, that is force is acted on taking rotational equilibrium about point O. About point O, we can write sigma tau will be equal to 0. That is clockwise torque will be equal to anti-clockwise. Hence we can write the torque due to this weight W will be clockwise and this load alpha W is also clockwise. W is at a distance L by 2 and this distance is given as L. Hence we can write W multiply by L by 2 plus alpha W multiply by L will be equal to T sin 45 multiply by L. On solving this, we can write T upon root 2 will be equal to W by 2 plus alpha W, since we cancel out L on both sides. Or we can write T equal to root 2 times W by 2 plus alpha W. This is equation first. This is equation first here. W by 2 plus alpha W multiply by root. On taking translational equilibrium, equilibrium in horizontal as well as vertical direction. We see that NV plus T sin 45 will be equal to W plus alpha W. We see that sigma FT equal to 0. So we can write N plus NV plus T sin 45 will be W plus alpha W, or we can write NV plus P upon root 2 will be equal to W plus alpha W. On putting the value of P from equation first here, we can write NV plus 1 upon root 2 multiply by root 2 times W by 2 plus alpha W will be equal to W plus alpha W. Here we cancel out root 2 from root 2, hence we can write NV will be equal to W plus alpha W minus W by 2 minus alpha W. So that is equal to W by 2. Hence, vertical component of normal reaction at 4 is independent of alpha. Okay. Next, on taking horizontal equilibrium, we can write sigma FH will be 0. We see that the horizontal force in this direction is Nx and in this direction is T cos 45. Since the length of the rod is constant and rod is in horizontal equilibrium, hence Nx will be equal to T cos 40. Okay, we can write Nx will be equal to T cos 45. That becomes T upon root 2. On putting the value of T from first equation first here, we can write Nx will be equal to 1 by root 2 multiply by root 2 into root 2 into W by 2 plus alpha W, W by 2 plus alpha W. We can write Nx will be equal to W by 2 plus alpha W. If alpha equal to 0.5, then or alpha equal to half, then we can write Nx will be equal to W by 2 plus W. So that will be W, and the second option is also correct. Now, the tension is given here T equal to root 2 W by 2 plus alpha W equal to root W by 2 plus alpha W. First, we have to calculate the tension. In the rope is 2W and 4 alpha equal to 0.5. If alpha equal 0.5, then T will be equal to root 2 W by 2 plus W by 2, or that becomes root W, and option C is incorrect. Option C is incorrect. Next, we have to check where the rope will break or not. We have to check the last option, the rope break if alpha is this alpha is greater than 1.5. Since T equal to root W by plus alpha W, and T breaking will be equal to root W. So, if the right hand side will be less than 2 root 2 W, then the rope will not break. If the right hand side is greater than the T breaking, 2 root 2 W, the rope will be break. So, we have to write the value of T root 2 here and calculate the value of alpha. That is 2 root W will be equal to root W by 2 plus alpha W. Or we can write 2W minus W by 2 will be equal to alpha W. Or we can write alpha will be equal to 1.5. Hence, up to alpha equal to 1.5, the rope will not break. The rope will break when alpha is greater than 1.5. It means the rope will break here. So, the last option is correct. Hence, we can say that the correct options are A, B, and D. This is the basically. Don't